Okay, welcome back. Answer your attendance. Afla,
Present, Miss.
Ajmina,
Present, Miss.
Amaya,
Present, Miss.
Adulya, Drishya, Jyotish, Karthik, Kavya, Nachdev,
Present, Miss.
Neeraj. Neeraj is there. Rangeet. Okay, Vaishnav.
Present, Miss.
Vaishnav. Vaishnav is not there. Anjali and Shruti.
Present, Miss.
So Neeraj and Vaishnav has not joined. Okay, so in the first morning class, we were discussing about classful addressing and the different types of blocks as well as the block size in each class. I hope you understood what is the meaning of blocks and what is the meaning of block size. Okay, now what are the advantages of classful addressing? I have told about the disadvantage of classful addressing because what are they? When you are comparing, when you are considering class A as well as class B addresses, much of the addresses are wasted. And also, when you are considering class C, it is not able to provide sufficient addresses to the organization. Okay, so that is the disadvantages of classful addressing. But there is one advantage in classful addressing. Now, what is that advantage? You can easily find the class of the address. Since you are having a specific limit for each classes, so class 8 is varying from 0 to 127. So you can easily identify the class of each address. So that is the advantage of classful addressing. But due to the disadvantages of classful addressing, it is being obsolete now. It is not there. Classful addressing is not there. Okay, now what is the main reason for that is address depletion. The main reason for the classful addressing to become obsolete is address depletion. Address depletion means deficiency, address deficiency. So that is what I told. When you are considering class C addresses, that many addresses, that is 256 addresses only you can provide it to an organization, and that was not sufficient to satisfy the needs of a particular organization. Okay, so in order to reduce that address depletion, two strategies were proposed. One strategy is called it as super netting and the other one is called subnetting. So in order to reduce or alleviate this address depletion, two strategies were proposed or implemented. One is called as the super netting and other one is called subnetting. Now in your syllabus, subnetting you have to see in detail. Now I will tell what is the difference. Super netting means you are having many small blocks and you will be combining it into a larger block. That is the meaning of super netting. So as far as class C is considered, if you are making use of many blocks in class C and making it as a large block, and there the concept of 256, there the concept of super netting comes. That is, many 256 addresses are available now. Okay, but what is subnetting? Subnetting means division of a network into many networks. Division of the network is called it as subnetting. So you should identify these two. You should know what are the two terms, meaning of the two terms. One is subnetting and the other one is supernetting. Subnetting, division of a network. Supernetting means a combination of many small networks. Okay, so supernetting concept is what I told us with respect to class C. Many class C blocks can be grouped together and make it as a large block, and that can be made attractive to the organizations. Okay, now coming to the subnetting concept in detail. I have told you there is, when you are considering an organization, I have told you are having many classes of address like class A, class B, and class C. And the first address of each class or each block is nothing but the network address. Okay, so the routers outside the organization make use of this network address. If they want to deliver the packet to the correct network or the correct destination, they make use of the network address. So the meaning is, I have told the IP address is 32-bit long and it has been divided into net ID and host ID. So you are having a separation. The whole 32-bit, you can have a network ID as well as a host ID. And the network address is nothing but making the host ID to 0. The first address in each block is called it as the network address. So when you are considering classful addressing, there is a level of hierarchy. Each address or each class address is divided into a net ID and host ID, right? So you are having a level of hierarchy or a sense of hierarchy in IP addressing. So if you want to deliver a packet to a particular host, first where you should reach the network first using the net ID. And after that, you have to reach the host using the host ID. Understanding? I have told IP address, there is a level of hierarchy. That is called two-level hierarchy. Two-level network with two levels of hierarchy. So if I want to deliver a packet to a particular host, then I have to reach to the network first. And then I have to reach the host. And that is done with the help of network ID as well as the host ID. Okay, so IP address are designed with two levels of hierarchy. Right? So you can see in the diagram, you are having a network, a main site you are having. Once you reach the network, many hosts will be connected to that. Okay, through the router R1 only, they can identify the network. Okay, now, sometimes many organizations, they need to assemble their host into groups. So you want what is required is I have told you are having a network and you will be having the host. But sometimes it is necessary that the host must be grouped together. Then the meaning is the network should be subdivided. As an example, if you are considering a university. So university, you know, you will be having several departments. Okay, so several departments is nothing but they are making a few group of hosts. Like mechanical department is in one group, electronics department is one group. The meaning is the whole network is, the university has one network address but several other network addresses are needed and they are called it as sub-networks. Okay, understanding? So the outside world, they knows the organization by its network address only. But inside the organization, you will have many sub-networks. That is the concept that has been shown in this slide. So the current slide, you are having a main network and you will have many sub-networks. Okay, so you can see it in the diagram. Is it clear what is sub-networks? So the network is divided into many small networks or subnets, and each subnetworks is identified with the subnetwork address. So two addresses, you are having network address as well as you are having subnetwork address. Okay, so the outside world, they know only the network address. Okay, but inside the organization, each subnetwork is identified by their subnetwork address. So that is the concept of subnetting, division of a network into small networks. Okay, so if we are dividing the network into several subnets, how many levels of hierarchy you will have? You will have 3 levels of hierarchy. One is the network ID, the other one is the subnetwork ID, and the third one is the host ID. The meaning is once you the main router you will have, it will be making use of the network address, and once it reaches, it will identify where the packet has to be delivered, and they will identify the subnetwork if it is there, and from the subnetwork it will be passed to the corresponding host. Understanding what is the meaning of subnetting? Yes or no? Subnetting means you are dividing the networks into small networks. Okay, so the hosts are, instead of having all the hosts connected to the main network, what you are doing is you are just grouping the host into, you are grouping the host. That concept is called it as subnetting. Understood? Yes or no? Yes. Okay.
Yes, miss.
Okay. Now, just so I have just told, you will have 3 levels of hierarchy. One is the main network ID. The other one is the host ID. I mean, first it comes the network subnetwork ID and then the host ID. So the net ID is the first level, and that defines the site address. Okay, so the second level is the subnet ID. It defines the physical subnetwork. Now the third is the host ID. That level is the third level is the host ID, and it defines the connection of host to the subnetwork ID. So if you are having an IP address like 130.11.2.21, so the first 2 bytes, in which class it belongs? 130. In which class it belongs?
Class B.
Class B. So class B, how many bytes are used for net ID?
2.
2 bytes. So 130.11 is considered as the net ID. And the other byte is nothing but the subnetwork ID. And the last byte will be the host ID. So if you are doing the subnetting process, you will have a net ID, you will have a subnetwork ID, and then you will have the host ID. Okay, so routing, the meaning, it involves 3 steps. One is delivery to the site. Second one is delivery to the subnetwork. And the third one is delivery to the host. Okay, so I have told, what I have told is IP address. In general, it is a 2-level, it consists of 2 levels of hierarchy. You will have the network ID, many hosts will be connected. So outside the organization, the router knows only the network ID, and making use of that, it will be routing the packets. But sometimes it is necessary that the host must be grouped. And that process, that term, you can call it as subnetting. The meaning is the big network is divided into small network. So if you want to reach the subnetwork, you need an address, and that is called as the subnet ID or the subnetwork address. Okay, so subnetting, without subnetting and with subnetting, what is happening? Right? Now, if you want to implement the subnetting process, the main router actually, it needs a mask. That mask is called it as subnet mask. I will tell what is that mask and all, just you understand. If you want to implement subnetting process, the main router that is outside the organization, the router that is connected to the rest of the internet, that is called as the main router. Okay, so the main router, it needs a subnet mask to indicate which is the network address, which is the subnetwork address, and which is the host ID, which is the net ID, which is the subnet ID, and which is the host ID. Now, what is mask? Mask helps you to find out net ID and the host ID. Mask help you to find net ID and host ID. So the one type of mask is called it as the default mask for classful address. Default mask. Default mask is nothing but it is a 32-bit binary number where you will have contiguous zeros as well as contiguous ones. Contiguous means sharing of zeros and ones. So default mask is nothing but it is a 32-bit number which consists of a continuous ones as well as a continuous zeros. Okay, so the router outside the organization, it is having a routing table. I told all the routers will be having a routing table and the address will be in that. Okay, that is based on, and there will be one column that will be based on the network address. Routing table and all you will be studying in the next module. Now you just understand you will have a routing table and the network address will be present in that table. Okay, now the router inside the organization also has a routing table. And that is based on, so you will have your sub-network address in that. Okay, so what is the key between this network address as well as the sub-network address is nothing but the mask. So routers outside the organization, they make use of this default mask, what is displayed on the slide. And the routers inside the organization, they make use of subnet mask. Two types of mask I told. One is the default mask and the other one is the subnet mask. So default mask is required outside the routers that is connects to the rest of the internet. That is the main router. And inside the organization, you require the subnet mask. Okay, now what the table shows. Now I have just defined class A, class B and class C. And you have the values of mask in each class. So when you are considering class A, you can see the first 8 bits are ones and the remaining 24 bits are zeros. So class A, the default mask is 8 ones and 24 zeros. The corresponding dotted decimal is 255.0.0.0. Okay, now for class B, 16 continuous ones you are using and 16 zeros. That is the default mask value. And the dotted decimal is 255.255.0.0. Now class C, it has 24 ones and 8 zeros. Okay, so what is the meaning is the number of ones it preserves or retains the network ID. And the zeros sets the host ID. Okay, so wherever ones are there, that value will be retained, and wherever that zeros are there, that value is marked it as 0. I will show an example, that time you will better understand that. Now on the right hand side, you can just see CIDR, C-I-D-R. You will be knowing what is CIDR in next class. So now you just remember this class A mask can be, all these values of this mask, they can represent in a slash notation in an easier manner. Okay, so that is slash followed by the number of ones. So that notation is called it as slash notation. So in class A, it is denoted as /8. What is the meaning of that? You will have 8 number of ones. Okay, so /16 means 16 ones you have. /24 means 24 ones you have. Okay, so what I told is, if you want to identify the network address, if you want to identify the subnetwork address, you need the concept of masking. So outside the organization, if you want to identify the network address, you require the default mask. And you will have many, the different values, the default mask values for each class is shown. Okay, so what it is written is the network address can be found by applying the default mask to any address in the block. Now what it does is it retains or preserves the net ID of the block and sets the host ID to zeros. Okay, so the number of zeros. Now, as an example, I will just show what is the meaning of that. See, suppose, I hope you can see the slides. Now, see the example. A router outside the organization receives a packet with destination address 190.240.7.9. Show how it finds the network address to route the packet. You are having a destination address. You have to deliver your packet to that corresponding address. Okay. Now, how the router will be routing that packets? So, in order to do that, the router should follow 3 steps. First step at any cases is you have to identify which class, to which class the address belongs. Now, tell me to which class the address belongs. 190.240.7.91. Look onto the first byte. The value is 190. So, to which class it belongs? To which class it belongs?
B.
B. Class B it belongs. Now, class B, you know what is the default mask value. That is just displayed just earlier. Now, what is the default mask value of class B? It is 16 ones and 16 zeros. So you will be making use of that mask. That is 255.255.0.0 is the mask value. Now what you are doing is you are just doing the ANDing operation. AND operator with the destination address. Now, wherever the 255 value is there, that address is retained. And wherever that 0 value is there, that value is set to 0. You know what is the AND operation. So here, if 255 it comes, the mask value, that is the boundary level mask value is coming, that is 255.255.0.0, you are ANDing with the destination address. So what you are obtaining is, first byte, it is 255. So that value will be retained. So you will have 190. Okay. Now the second byte, look on to 240. But the second byte of the mask is also 255. So that value will be retained. So it is 190.240. The other 2 bytes, the mask value will be 0. So automatically that destination address value will be 0. Okay, so you are obtaining the corresponding network address 190.240.0.0. So the router, it will look onto the routing table if the network address is available, and it will be routing packet based on the network address. Understood how you are delivering the packet, what a router does when it receives a destination address. Understanding? Yes or no? Yes, okay. Somebody should respond, so otherwise, okay. So what I told is the default mask value or the boundary level mask value. Now look onto this slide. So I have told without subnetting also you can do, with subnetting you can do. Now, what is the difference? Without subnetting, what address you will be getting, and with subnetting, what address you will be getting. Now, suppose my IP address is 130.11.2.15. Now, if I'm applying a mask, that is first case I'm telling without subnetting. So without subnetting means you have to understand that the 255.255.0.0 will be the mask value, default mask value, and what you once you apply the mask with the IP address, what value you will be getting. This is the example what I have told now. You will be obtaining the network address. So 255.255, that value will be retained. So 130.11 will be retained. So the remaining 2 values will be 0. Okay, so that will provide the network address. Now, if I am doing subnetting process, now what will be the mask value? You will have 255.255.255.0. Okay, so wherever the 255 values will be there, that values will be retained or preserved. So 130.11.2.0 will be the subnetwork address. So remember that 4 bytes, the first 2 bytes is denote the network ID. Okay, there is no change in that. Now, the third byte defines the subnetwork ID. And the last one will be the host. Okay, so that is the concept of without subnetting and with subnetting, what is happening. Right? Now, you will have, sometimes questions may be asked, you have to find it out, what is the subnetwork address. In order to find out this subnetwork address, you should remember two levels of masking. One is called it as the boundary level masking. The other one is called the non-boundary level masking. Okay, one is the boundary level masking. The another one is non-boundary level masking. Now, what is this boundary level masking? Boundary means the values are at the boundary. Boundary, which are the boundary values? 0 and 255. It will be either 0 or 255. So, if the mask values are 0 or 255, it will be easy for you to find the subnetwork address. Now, what you have to do is what we have seen in these many examples. Wherever the 255 value is there, that value will be retained, and 0 value, that will be crossed. That will be marked as 0. So the bytes in the IP address that corresponds to 255 in the mask will be repeated in the subnetwork address. That corresponds to 255 only. It will be repeated in the subnetwork address. These many examples we have seen. Okay, now if the bytes, if it is 0, about 255, I told the value will be retained. Now what about 0? The mask will change to 0 in the subnetwork address. If the bytes in the IP address, if you have 0 in the mask, it will change to 0 in the subnetwork address. So that is the, you have to understand in boundary level masking. Now, what happens in non-boundary level masking? So this is just an example. So example also I will just tell. Your IP address is 30.15.10.6 and your mask value is 255.255.0.0. Okay, how will you find the subnetwork address? You have to identify whether the mask is at the boundary level. So if it is at the boundary level, and you have to identify whether the value is 0 or 255. So if it is 255, that value will be retained. So here 30 is retained. 15 is retained. But what about the other? The other two are not retained. The values will be 0. Understanding what is boundary level masking, how you have to find out the subnetwork address if an IP address and the mask is given for you. Okay. Now, the second level of masking is called the non-boundary level masking. The meaning is the values of the mask, they are not at the boundary. They are not just 255 or 0. If they are not 255 or 0, how will you identify the subnetwork address? Now, how you have to do is, you have to do the bitwise AND operation. You have to do the bitwise AND operation. As an example, suppose the IP address is 30.125.10.6 and your mask value is 255.192.0.0. So what is the first step? If you want to identify the subnetwork address, you should identify what is the mask value. And you have to identify whether it is boundary level or a non-boundary level. So the first byte, if you are considering, the mask value will be 255. So the corresponding IP address value is retained. Okay, 30 is remaining. Now the second byte, if you are saying, the mask value will be 192. That is not at the boundary level, it is at the non-boundary level. The meaning is it is not 0 or 255. So what you have to do in that case is you have to do the AND operation. How you will be doing AND operation is the corresponding binary values of 125 and 192 you have to consider. So 125 corresponding binary you have considered, 192 you have considered, you are doing the AND operation. Once you do the AND operation, a value you will be getting here, the value corresponds to 64. So that will be the address part. 64 will be the one byte of the subnetwork address. And remaining 2, it is 0, so zeros are placed. So subnetwork address can be found out from an IP address and a mask by this. Identify non-boundary or boundary level masking. If it is non-boundary, you have to do the AND-wise operation and get the subnetwork address. Understood? What are the two types of, how you are, what is default mask, what is its meaning, and how you are able to find out the subnetwork address from the mask. Okay or not? Yes or no?
Yes, Miss.
Yes. Now, what are the advantages of this subnetting process? Very, very important. Sometimes in the exam it might be asked. Now, what is the advantage of subnetting? The first one is you have to write it in these terms only. It helps to aggregate information. It helps to aggregate. Aggregate means combining several separate elements. So that you can do with the help of subnetting. The meaning is you will have a mini collection of physical network and you will be all, that can be made to look at it as single network. See, the router outside the organization, they know only a single network. But that single network will be divided into many sub-networks. Okay, so that possibility is done with the help of subnetting. So that is the meaning. It helps to aggregate information. That is, a complete collection of physical networks can be made to look like a single network. So the amount of information that each router needs to store is reduced. See, assume you are having that is the disadvantage of supernetting actually. Actually, supernetting, what I have told is you will have many separate blocks and you will be combining it into a main block. Okay, but what is the disadvantage is the routing table. It is not able to identify, and it is difficult to route the packets when the network is supernet. Okay, but if you are doing subnetting, that processes, what all informations the routers should contain, that is minimized in this case. Okay, so that is the one advantage of subnetting. It helps to aggregate information. And the second advantage is address assignment, improves the address assignment efficiency. Okay, so whenever you are adding your new physical networks, you don't want to use the entire address again and again. Every time whenever you are adding your physical address, if you want to add a new subnetwork, that is not required that the entire address should be needed. So it improves the address assignment efficiency. These are the two important advantages of subnetting. One is it helps to aggregate information, and second one is it improves the address assignment efficiency. Okay, so this is the concept of subnetting. Now, okay, next class we will be learning about classless addressing. So I will wind up today's class. What we have seen is, what are the things that we have seen from morning class to this class? Can anybody summarize it? We will be summarizing. Neeraj is there. Neeraj and Vaishnav. Yes or no? Neeraj. Neeraj is not there. Vaishnav is there? No. Okay, 1, 2, 3, 4, 5, 6, 7. Only 7 are there.
They're absent.
Who's one more left here? Afla, Ajmina, Amaya, Atulya, Illa. Kavya, Nachiket is there. Then Neeraj is not there. Rankeet left here. Okay. Vaishnav and Vaishnav. Okay, Vaishnav, you can summarize today's talk.
Net ID and host ID.
The morning class, what I have told is about the blocks. What you understood from that? Blocks. What is the what you know about blocks in classful addressing? How many blocks are there in each class and how many addresses is it is possible with each block?
Class A 128 blocks.
What is the meaning of that? 128 blocks means that many organization can be provided with class A address. Okay. Now, what is the size of that?
16,000,007.
Okay, 16,677,000, etc. Okay, so what is the main thing is that is one of the problem of classful addressing. You are having everything in a fixed value. So the classful addressing is obsolete now. Okay, so that many addresses you are not at all making use of because class A, it is meant for large organization, but if it is large also, that many addresses were not at all required to satisfy the needs. So it is address was wasted. So you were going to classless address. Okay, so it is classful is almost obsolete now, right? Now, after that, what we have learned? So morning I have just told how many number of blocks and what is the size of each block, and I have told, and I have also told about the network address, right? Now how will you find the network address? How will you find? Yeah.
Class A.
No, generally you are having an address. Now how will you find it? You will have a destination. How will you find the network address from that? First step is Ajmina.
Miss.
Tell. How will you find the network address?
First number ഏത് ബ്ലോക്കില്
The class. Okay, to which class it belongs. Okay, then.
net ID.
Net ID will be. എന്താ ചെയ്യുന്നേ? You will have network ID as well as the host ID. So, net ID you will keep as it is depending upon the class, and the host ID, what you will be doing?
20.
Yeah, almost you have to make it to zeros. Okay, so that was the thing that you studied in the morning class, and after that you have gone with the concept of subnetting. Now, what is the importance of subnetting? What is the importance of subnetting? Nachiket, answer. Yeah, tell. What is the importance of subnetting? Okay, what is subnetting first? Nachiket?
Yes.
Yeah.
Hello.
Subnetting.
Into many small network, a division of network into many small network. Hello, ma'am.
Yeah, make it fast.
Division
Unique
of network.
process. And I have told the advantage. Yeah, division of network into small networks. And I have told what is the advantage of subnetting. Two advantages, very, very important. Okay, so when you are doing the okay, now when you are considering subnetting process, you will have 3 levels of hierarchy. You know, if it was not subnetted, you will have only 2 levels: network ID as well as the host ID. Main network and host are connected. But once you do the subnetting process, you will have 3 levels of hierarchy. You have to reach the network first, then you have to reach the subnetwork, and then you have to reach the host. Okay, now I have told what is mask. If you want to get the subnetwork address from a ALPA address, you require the mask. Mask is acting as the key there to identify the network address as well as the subnetwork address. So default mask I have told, that is a 32-bit binary number with number of ones and number of zeros. It depends for class zeros, like that for all classes. So with that value, you will be able to identify the network address. Okay. Now, if you want to identify the subnetwork address, you require the subnet mask, right? And that is how the extraction. If you have to check whether the mask value is at the boundary level or the non-boundary. If it is non-boundary, you have to do the AND operation and get the subnetwork address. Okay, I hope it is clear for you. And today only you read the textbooks. Your series test for this is 5th of October. And I have told you about the unit test also. That also 5 members. You have to comment on that time and attend that exam and prepare well for that exam. Okay, thank you.